boys and girls, let's see here. I'm working on homework with you. You open this document in the classroom under the homework assignment. Yours looks just like this. I've got my paper out. I've written up at the top. I've put my name and the date and Pythagorean review and homework. And I've got my tools out for solving math problems. Okay, you're going to read the problems and solve them to the best of your ability. If you're having trouble, you're watching a video. Okay, number one, I'm working through these problems. You're going to stop as you need to and watch what you need. Number one, the distance across the pond cannot be directly measured. A land surveyor takes some other measurements and uses them to find D, the distance across the pond. Okay, so you're trying to find, it says, what is the distance across the pond? All right, so what is D? What is D? Or the distance? Now I'm going to use the Pythagorean theorem, right? The Pythagorean theorem is a squared plus b squared equals c squared. A and B are the legs. You guys know this stuff. I draw this diagram out, right? I've got one leg around that lake is 40 meters, and the other leg is 30 meters. Okay, and D is this diagonal that goes across the lake that they've drawn there. Okay, so A equals 40, B equals 30. So 40 squared plus 30 squared equals D squared. Those numbers came from here and here, and that's 1,600 plus 900 equals D squared. So the square root of both sides, the square root of 2,500 equals the square root of D squared, right? And we took the square root because we want to know what D is, and that's going to be 50. So it's 50 meters across that lake. Alright, so you're going to keep working on your paper. You're going to be solving problems kind of just like that. Okay, number two, you're going to draw that thing out again. Right, it says on a map below, the post office is at the origin 0, 0, and each unit represents 1 kilometer. Amy lives 6 kilometers east and 8 kilometers north of the post office. If she rides her bike directly from her house to the post office, how far will she ride her bicycle? Well, let's see here. I'm gonna work on my tablet, okay? And you guys can probably do the same thing on your screens, right? A dry erase marker on those screens can actually work. So this is asking me, if she rides her bike directly from her house to the post office, how far will she ride her bike? Well, her house, right? Amy's house is right here, and then the post office is right here. And I'm trying to find the distance between those two. And I could use the distance formula and the coordinates of those 2 points, or, right, I could draw a straight line out. Let's see here. If I draw a straight line out from the post office, and I draw a straight line down from Amy's house, I can create a right angle. Okay, so I've got a right angle that's created right here. Oh, let me see. Right here is my right angle. Okay, so this is my hypotenuse, this is C, and then A and B are these sides. And I just count the number of units, right? I went out to 6, so A went from 0 to 6, so that's 6 units. And B goes from 0 all the way up to 8, so B equals 8. Okay, so 6 squared plus 8 squared equals the long side, the hypotenuse, or the distance between Amy's house and the post office. And 36 plus 64 equals 100. And the square root of 100 equals 10. Okay, so this is one of those common 3, 4, 5 triangles. The ratio is 3, 4, 5, right? If I divide 6, 8, and 10 by 2, I get 3, 4, and 5. So my answer choice there is B. Okay, number 2, the answer is B. Let's see, in number 1, We found that it was 50 meters. We found that it was B. Sorry I didn't get that one with you guys. Okay, then number 3. Let's see, number 3 over here. The solid lines below show the route Maddie's bus takes to school. All right, the solid lines show the route to school. Okay, so here's Maddie's house to the school. Solid lines, right? Solid lines show the route Maddie's bus takes to the school. The dashed line shows the shortcut she takes through the park when she rides her bike to school. The dashed line shows the shortcut through the park when she rides her bike to school. So this line right here is my shortcut through the park. What is the difference in kilometers between the shortcut and the usual route? All right, so the usual route is 12 plus 5. Right, so the usual route is equal to 16 kilometers. That's the usual route. Now, if I want to find the distance across the park, right, I can take, I'm going to call this A and this B. These are my legs, and this is going to be C. So let's see here. 5 squared plus 12 squared equals C squared. And this is another one of those common ratios, right? This is a 5, 12, 13 triangle, right? This is 169 is equal to C squared. You're using your calculators to solve these problems, right? You can use your calculators as I'm writing and then stop the video and go back, right? Let's see here. So 13 is equal to C. So let's see here. The difference, what is the difference in kilometers between the shortcut and the usual route? Well, the usual route is 17 kilometers and the shortcut is 13 kilometers, right? And the difference means subtract 17 minus 13 equals 4 kilometers. So the difference should be 4 kilometers, so the answer is C. Okay, that's number 3 in the homework, and I'm going to keep going. I'm going to go to number 4. Okay, and you guys keeping right up, following along, solving the problems in your calculators, and then getting the work down on paper. Let's see, we're talking about a quarterback throwing a pass to another player. We've got the sidelines over here. It's kind of the y-axis, it looks like. The y-axis is the sidelines, right? And then the x-axis shows us the distance from the sidelines. So the y-axis is the sidelines, and every increment is 5 yards. Okay, to the nearest yard, what distance was the pass thrown? Well, we could use the distance formula, right? We could identify those 2 points, right, as 25, 30, right? That's the other player. That's OP is at 25, 30, and the QB is at 15 and 15, and we could use the distance formula. But on this coordinate plane, it's really kind of nice because we can identify the 2 legs, right? If I draw a straight line out from the quarterback and I draw a straight line down from the other player, right, I've created this right triangle. I've created a right triangle, and the 2 legs, let's see, are 5, 10. Okay, 15 to 25 is 10 yards, and then I went from 15 yards all the way out to 30, so I have 15 yards over here, right? So my 2 legs are 10 yards and 15 yards, and my hypotenuse is the distance that that quarterback threw the ball. So I'm going to use my Pythagorean theorem, and I'm going to plug those values in. A is 10, and B equals 15, right? So A is 10 plus 15. Square both of those values and add them together to find the hypotenuse, or the square of the hypotenuse rather. And that's 100 plus 225 is 325 is equal to C squared. And the square root of 325 is equal to the square root of c squared, or c. And so c is approximately 18.0 yards. 18 yards. C is the choice. Okay? And that's your homework. And we're all done there. And I hope you have a better understanding. And if you still have questions, you should be reaching out to ask me. Thanks, boys.